To set the scene and to give a little bit more context for the current state of MLOps, I'd like to introduce to you a character who has been involved in the scene a long time and indeed was one of the founders of the MLOps community, along with Dimitrios Brinkman, who we're going to meet in the bar in a minute. So from Cluster HQ through .science and now to MLOps Consulting, Luke has been pushing the technical boundaries because that's what he does best. So it's my real pleasure to introduce to you what I'm calling Mr. MLOps himself. And I'll cede the floor to Mr. Luke Marsden. Thank you, Luke.
Awesome. Thank you, Nick. Cool. Well, hi, everyone. Thanks for coming to this virtual event. I'm going to quite quickly go through what I'm calling the state of MLOps, and try and give you kind of a map of the space as I see it, which might be helpful when you're navigating the rest of the day and some of the talks that are coming up. So first we can try and just answer the question, what is MLOps? Well, MLOps is the intersection of software engineering, DevOps, and machine learning. And because it's more than just the intersection of software engineering and DevOps, we're adding this additional circle in the Venn diagram of machine learning. Because machine learning depends on data, it also pulls data into the process of doing DevOps in a way that it hasn't been done before. And that does introduce challenges. Now, someone showed up in the MLOps community the other day, and their opening salvo on Slack was, MLOps is just more DevOps. It's just DevOps. Like, what are you making such a fuss about? Why are you trying to build a whole community around this thing? And I want to point out, I'm going to try and tackle that claim by explaining, and I'll kind of get to the conclusion at the end is yes, it is more DevOps. It is just more DevOps, but DevOps has to level up in order to succeed with machine learning as well as part of the challenge. Now, that's because software is a function of just the code that's written, that's compiled, and the environment that's built in. So you could think of it in terms of this very simple formula. Software is the function compile that takes code and environment as the arguments, right? Fundamentally, that's what we're doing with DevOps. We're taking code, we're compiling it, packaging it, deploying it to production, monitoring, and so on. And this formula is really at the heart of DevOps. But machine learning models are a function of the data that they're trained on and the parameters that are used when training those models as well. And so the formula for machine learning is more like this. Model equals train of data with parameters and code and environment. And if we take a look at some of these arguments in these functions and the functions themselves, then they are different. They're fundamentally different. And for one thing, data is in here, and I'll talk about data a lot because it does add a lot of complexity. There's also the parameters that go into training models. Keeping track of parameters isn't that hard. It's just metadata tracking, but it is something you need to do. And there's a whole space of kind of experiment tracking that happens around that. And then the train function itself. Compiling code is normally quite fast, especially with modern programming languages like Golang, where typically if your code takes more than 30 seconds to compile, then something's wrong. Whereas training a model on data is very computationally intensive. It's non-deterministic, and sometimes it's distributed across multiple machines, and that does add complexity. And now monitoring the thing that you've deployed is also very different, because just keeping track of latencies and error rates is no longer sufficient. When you're looking at understanding the behavior of a model that's running in production, you really need to think about a lot more complex things like the statistical distribution of classifications that a model is making in order that you can get a handle on understanding the behavior of that model once it's running. Now, I want to talk about reproducibility and provenance. This is something that DevOps people take for granted. In DevOps, we know where our deployed artifacts came from. Like, we typically deploy a Docker image into a Kubernetes cluster most of the time these days, and we know where that Docker image came from. It normally came from the CI system compiling a certain version of the code that came from version control in a certain environment, which is specified by the container image that's used for building the artifact. Like, but let's take a pause and imagine if we didn't. And so what I mean by that is that the DevOps process is reproducible, fairly reproducible anyway. You might not get exactly the same binary bit for bit every time you compile it, but you'll get something that's functionally equivalent. And you know the provenance of where your code came from. It's all there in your version control system. But imagine for a second if you couldn't keep track of, if you couldn't reproduce the same functionally equivalent artifact, and imagine if you couldn't understand where your software came from. It would make software engineering a lot harder. It would make DevOps a lot harder. We wouldn't be able to debug our software. We wouldn't be able to keep track of our changes very well. And when something goes wrong, I mean, we're software engineers, right? We know about what it's like to try and track down and isolate a problem when there's a bug or some bad behavior in production. And if you can't isolate what went wrong because you can't reproduce things and you don't know what's changed, then you're really kind of at sea, as it were. So you really don't even know if you fixed a problem. So machine learning makes reproducibility and provenance of DevOps harder because you need to keep track of the data and because you need to keep track of parameters. And you need to do that to the same level of quality and rigor that you do with version control of your code. And I also just want to share a little bit about, so what does it look like when this goes wrong? So in my experience with dot science and speaking to many companies across many industries trying to do machine learning, and also some more recent experience with MLOps consulting, what it looks like when things are done badly. I've seen a surprising number of companies who they're just like, oh, I can't even deploy my models. Like I have my data scientists in this team over here in this silo trying to get their models deployed, and they have to wait months before they can get these things into production. And because there's some kind of conversation that happens inside some big company where a data scientist gives a DevOps person, they email them a Jupyter notebook, right? And the DevOps person says, what is this? What do I do with this? I don't know how to get this into my production cluster. And I've seen some companies where you even have to translate your models into Java before you can deploy them, which is going to slow things down. And then you have a whole problem of validation, of understanding whether your translated version. But anyway, there's also the problems of kind of unmonitored models. Once you've deployed models into production, understanding their behavior. I've seen a lot of teams trying to do manual tracking with spreadsheets. And kind of the DevOps equivalent of this is, imagine if your CI system was a big spreadsheet that you kept track of manually, where every time you built a Docker image and you pushed it into a cluster, you added a new row to the spreadsheet. And this is kind of crazy from a DevOps perspective, but it's often the status quo for ML, just because the maturity of the process, the teams, and the tools that people use isn't there yet for MLOps. Another problem you often see is that people get knowledge siloed in their heads. Only Bob knows how this model was made, for example, and maybe Bob goes and works for Google, and now we have to rebuild the model from scratch. And that's what I mean by key person risk. And another symptom of this problem is that lots of different team members will have their own techniques for keeping track of their work. Some people will use text files, other people will use a wiki, other people will write it down on paper. And this can all feel a lot like software engineering before version control. And so how do we solve this? Well, I'm going to come back to some slides that I used before from my dot science days here, because I still believe in the MLOps Manifesto, and this is something that we put up on mlops.community when I founded that community with Nic and Dimitrios. This is up there on the website, and this is kind of these are our guiding principles, or mine at least. Firstly, the systems that and the processes that you build have to be reproducible. That means a test for that is whether you can retrain a 9-month-old model to within a few percentage points of accuracy without having to go and talk to anyone. You have to be able to do that automatically. Another test is your model development process accountable? That means, can I trace back from the model that's running in production to where it came from, the provenance of that model? That includes the provenance of the data and where that data came from, which is it's normally a whole complex branching tree, and you need systems in place to capture that metadata. Is the model development process collaborative? That means, can I take something that Nic's working on and fork it and make my own changes and then propose them back? For people doing software engineering, this is like, yeah, of course you can. Just use GitHub and do pull requests. But when you've got data sets that are large, floating around, and all the other complexity, then that becomes harder. And then finally, can you deploy models continuously? And that means I want to be able to deploy my models automatically. I don't want any manual steps, any spreadsheets involved in deploying my models. And can I statistically monitor my models, which means can I understand the behavior of them once they're running in production by looking at statistical measures like the distribution of classifications that a classifier model is making. And so these 4 tests are tests that you can apply to your own teams and your own companies, and understand where you are kind of on a spectrum of maturity to see, like, how well am I doing, or am I likely to have problems trying to productionize my machine learning? And this kind of comes back to the original question of is MLOps different to DevOps? Well, yes, it is. I mean, it's more DevOps, but it's more complex DevOps. And the reason for that is that when you're doing software engineering, you go around this loop here, from code to test to deploy to monitor and back again. Whereas with machine learning and MLOps, you've got a much more complex kind of representation of the process that you have to go through. You have to do data engineering to get your data into a form that you can use to train a model. You need to extract features in your data engineering, so there's a whole world of feature stores and management of that. You have to get your code ready to train a model. You have to set the parameters for a model run. And throughout this whole process, what I've found is that it gets a lot simpler if you start thinking about tracking runs. That's the execution of a specific version of a piece of code against a version of data that generates certain model artifacts and certain metrics, rather than just thinking about versioning specific pieces of code. If you start thinking about tracking runs, then you're able to capture this additional complexity. And then you've got these model runs that generate model artifacts that get deployed into production and then monitored in the way that I've described, in terms of, for example, if you have an autonomous vehicle model that's driving around taking pictures of road signs and trying to classify them, then you might want to understand if the percentage of stop signs that your autonomous vehicle fleet is classifying suddenly drops to 0. So you need to have that new kind of level of statistical monitoring. And I know I'm short on time, but I did want to share this map because I promised you a map. So here's my map that I put together quickly this morning. It's not exhaustive. As Nic said, there are a lot of people working on this problem, a lot of companies, a lot of open source projects. But just very quickly, there's the whole world of data engineering, feature stores, and also pipeline systems. And I see pipeline systems as being kind of cross-cutting across data engineering, model training, and to some extent into deployment and serving. There's this whole world of feature stores, and we'll hear from Tecton this afternoon, I think, or this morning. There's pipeline systems like Pachyderm, Airflow, Kubeflow pipelines, and so on. And just to note that sometimes inference happens inside the pipeline system as well, so it's not that simple. Then there's the whole world of model training, experiment tracking, there's the question of notebooks versus code in the model training world. There's also the challenge of hyperparameter tuning once you're doing model training. And then there's deployment and serving. And I've kind of put Kubeflow in this box that spans model training and deployment and serving because it has components that do both. And for deployment, pretty much everyone is using Kubernetes now. And then we're going to hear from Clive, I think, about KF serving and Selden, which is an essential sort of part of the stack. And then in the monitoring category, I talked about kind of model and data drift, understanding the behavior of your models in production. You can use Prometheus and Grafana to kind of DIY some of this yourself, but then you have to instrument your models a lot. And then underneath the whole thing, I've put this box called governance, which is quite an enterprisey term. But I really do believe that you need a system, you need a process and tooling that covers this whole process, and obviously there are loops within this process, so that you have reproducibility and provenance tracking that goes all the way from my monitoring data told me my model is wonky, it's doing something weird in production, what data was it trained on? And you need that connectivity across the whole stack. And so there's a bunch of different approaches that people can take. If you want to have an MLOps platform, then you can either get an all-in-one platform that tries to bite off this whole thing here from a cloud or from a vendor, or you can build your own stack out of like a set of best-of-breed components. And there's a really interesting argument here, which I'm going to run out of time to make, but that people have said that look at how DevOps shook out. You don't have one big company that owns the whole DevOps platform. You have companies that are really good at monitoring, companies that are really good at deployment, companies that are really good at artifact management, and people have built big businesses around just these individual verticals. And so surely the same thing is going to happen in MLOps, and there won't be one big platform to rule them all. But that's also not what I'm hearing from enterprise buyers. So I'm not sure as to the answer on that question, but if you have opinions, please voice them on the platform. So you can also DIY systems with open source components, and I think we'll hear from Cookpad on how they're doing that with Pachyderm and Kubeflow and various other components. So it's up to you as to which approach is the right approach for you. Just a very quick note. I believe that there could be an all-in-one platform that's built out of best-of-breed components and is open source. I'm working on something in this space. I don't have anything to announce yet, but if you're interested, follow me on Twitter for updates. But yes, to conclude, MLOps is just more DevOps, but it's more complex. And as DevOps folks, you can keep your jobs, but learn how to tackle these problems. Otherwise, the data science and the machine learning teams that you serve will end up in a right mess. And focus on how complex it is to add data to this equation. Doing reproducible data-driven pipelines right is difficult. It's worth serious attention and focus. Go and study the Pachyderm datum model, for example. If you can go and understand how Pachyderm deals with datums, then a lot of this will just fall into place, and you'll be like, oh, okay. And anyway, with that, I just wanted to hand back to Nic.
Great. And thank you, Luke.
Yeah, watch out for the great talks today. Thank you.
Amazing. Thank you. Well, we don't have any applause, but we can do some studio applause, some polite studio applause. We do have a question in on the conference platform. So Phil Winder has a question for you.
Oh dear.
Thanks, Phil. Do you have any advice as to how to prioritize MLOps implementation? What is the most important or the least?
Yeah, so that's a great question, Phil. I think kind of there's a hierarchy of needs for this, and the most fundamental need is being able to deploy your models into production at all. If there's a long gap between a data scientist being able to create a model that looks like it will create business value, but it's in a Jupyter notebook on their laptop, like with a local data source, then if there's a big gap in time and effort between getting that model into production where it's creating business value, then you're not going to get any value out of ML. It's just going to be like sort of science project. And these models get stale really
bad.
quickly. So if it takes you 3 months to get your model into production, then it's probably not going to be as useful as it was when you started. So that deployment piece is the first priority. But rapidly after you see teams deploy models, then you need to understand the behavior of those models in production, so you need some monitoring in place. And then if you haven't got the monitoring in place, then you can get situations like models going out of control and no one noticing. And I heard one company say, we lost an immeasurable amount of money by having this model that went crazy. We don't even know how much money we lost because we weren't keeping track of it. But that sounds bad, right? Yeah. And then once your teams scale up, that's when you start caring about things like keeping track of, and you really should start doing this from the beginning,
I'm here.
Keeping track
Hey, can you hear me?
of models and provenance. But yeah, that's roughly the hierarchy of needs.
Great, thanks, Luke. So the results are in from the poll. Welcome to Bristech Production ML. I think we've now rebranded successfully. We're going to change. The 53% of you said that you prefer Production ML. So that's interesting. We are going to leave